Similar to what we had, the constraint equation, no? Similar to that. Laws of motion, I guess. Let me bring. So there's a system. So there are two pulleys are there, fixed pulleys. So I'll give the mass of the block here. MA 5 kg, MB 4 kg, MC 2.5 kg, mu 0.5. So the system is released from rest. Find the acceleration of blocks. Okay, carefully analyze, carefully analyze. You have to be very careful here. The mu for inclined plane and the block, it is 0.5. Pulleys are light and the string is massless. Pulleys are light and the string is massless. Okay, try this. Just I'll give some timer because some calculations are involved. It's not that straight away you can work out. Some calculations are involved. Pathfinder, I'll send it. Pathfinder PDF, I'll upload it. I'll upload it today. No problem. Yeah. So what to decide here? There's a big headache here, no? So what we have, the block is kept on inclined plane. Let's check tan theta and mu once. We'll see. We'll get any idea here. Tan 37. Anybody tan 37 value?
3/4.
3/4. 3/4. It will be, I think, is it tan 37 or theta? I'll write it. Is it tan theta greater than mu? The first tan theta is greater than mu from the problem. So what will happen to block A? There's no problem with the block A, no? It will shift. Because along with the weight, already tension is also going to act. So the block A, there's no problem. So the block A will shift here. And what about the block C? Yes, there's no problem. Block B also. So I don't know anything. I just proceed it. I'm not sure whether I'm right or wrong also. In the end, I'll cross check with some data whether I'm right or wrong. But the best way of the problem is like just get into the problem. The friction here, let it be F1.
Sir, is there a chance of tension being 0, sir?
Solve it. If you get 0, okay, 0. That's all, no? But seeing, we can't say anything here. I'll take another diagram. Okay, there's a question, so we'll proceed like this here. Okay, now the weight mcg will act. What is value of mc? Mc is 2.5 kg. 2.5 g, I'll write it, or mcg will write. Let this be the tension. So first the weight mcg will act, because of the strings will become taut. Let the tension, I'll show it here, T, and this is T. Here the friction, FB. Normal reaction, Na, MAG cos theta, MAG sin theta. Here normal reaction, NB. This is MBG. Let's have some values of friction in hand. It will be easy for us. Mu Na, mu MAG cos theta. So value of mu is how much? 0.5, 0.5, 5, 10, cos 37, 4 by 5. 25, so this will be 20 Newton. Similarly, FB is equal to mu MBG 0.5, 4 into 10, 20 Newton. Okay, so these are the frictional forces that are acting. And then we don't know, so let's assume that any constraint equation, AC, 2AC should be equal to AA plus AB. That I'm writing constraint equation. Acceleration of block C should be equal to acceleration of block A plus B by 2. Looking at the strings, that one. So there's a constraint equation. Let's write the equations on individual block. T minus T plus MAG sin theta minus F equal to MA into A. Okay, so the next equation again. T minus FB equal to MB into AB. For the block, MCG minus 2T equal to MCAC. How many unknowns are there? Acceleration of the blocks, tension. So I'll do one thing. I'll substitute expression for acceleration for block A, block B, block C in the above equation. Then I'll find out the tension. Then I'll come and check it. Is it what I did right or wrong? Okay, son, we have to solve it. There's no other way. We can't just leave the problem here only. We have to come and check it. There's a possibility that here tension can be negative. No, tension must be positive. So here tension, I think here any non-zero value will be sufficient for the block A to slide. Will I agree? What about here? For the block B to slide, what is the necessity condition here? The tension must be greater than the limiting friction here. But sir, we assumed it as we assumed. Okay, let's calculate the tension. You check the value of T. If the tension is less than FB, then what means it will not shift. The block B, if tension is less than FB, the block B will not shift. Are you getting this idea? So if you can, anybody give the value of tension, then I can conclude something.
Sir, 11.21.
11.21. Okay, fine, very good. Tension 11.21. Huh? Is it possible for this tension to overcome this FB? But something we assumed it, the block B will shift, no? But what we ended up with answer 11.2 Newton. So what I should interpret now? In fact, the block B will not shift. And the friction acting will not be limiting on the block B, will be static friction. Only A and C will move. So with this, what is the thing? Therefore, the block B will not shift. Got it, no? So whenever on inclined plane something comes, no, so you have to be a little bit alert. We can't just blindly come to the problem. We have to cross check. And now if the block B doesn't shift out the problem will become okay. This is so now only the block A and the block C will shift. MCG 2T. So I think this will be much easier. We know how to work out the problem. Now the problem has become very simplified here. So this is the normal contact, NA, tension, MAG sine theta, MAG cos theta. The friction here, FA. Here the tension T, T dash I'll call it. This will be some other tension T dash, which I don't know. So this will be T dash. Static friction equal to T dash. So let's write what is the constant equation? This will be a test. Will not shift. So only block A and C are moving. Any constant equation for them? If this moves by 1 meter, that will, so acceleration of block A equal to 2 times of acceleration of block C. Then the equations T plus MAG sine theta minus F equal to MA into acceleration of it. Then MCG minus 2T dash equal to MCAC. And now you can ask question like, sir, why you took some other tension? Why not the same tension? That was only cross-checking. Practically, this what happens. Practically, this what happens. So here, what happened? I'll do verify. I'll assume the tension T dash. You check it. This T dash will be different than that. Or let's leave it to the answer. We'll calculate this T dash. But how many unknowns are there? T dash, aggregation of NC. Three equations, three unknowns. Solving this, we'll get the required thing. Okay, now so what you have to be alert when only one block is there. We are very quite sure. When there are 2, 3 blocks are there, then there can be a possibility that one block will not shift, the other 2 blocks will be moving, or maybe the two, all 3 blocks may shift. It all depends upon the value of MC. I'll give the answers. You can cross check them. This will be the final answers. No, these are very important. Definitely in advance, no, they will try to trouble the students with these things, because the students usually just will is not bothered about to verify that tension is greater than FB or not. Then definitely you'll be in the wrong thing, no, because the block B will not shift here. Okay, no, so just you look at the tension value, calculate and check it. Is it equal to the earlier value? I'll introduce to the next concept, block upon a block.